Today I'm going to talk through some of the basic building blocks of programs, values, variables, expressions, and statements. I'm going to be dividing up my video into two parts just so you don't have to go searching through kind of a long 45-minute video. Begin talking about variables and values, naming conventions when picking the names for your variables. I'll later talk about statements, operators, and expressions, how and why to add comments into your code, and the use of the backslash and quotes. So what is a value? Values are essentially pieces of data, the smallest kind of building block of your program. Example values seen here on the left side of the slide include the number 1, the letter A inside of quotes, 3.14159, and the sentence, I am learning Python. All data values will have a data type. Of these examples, we see 3 common types: integer, string, and a float, floating point number. Integers are simply numbers that have nothing to the right of the decimal point. There is no decimal point. Strings are any sequence of alphanumeric characters enclosed in quotations. Here we see a lowercase a or a sentence, I am learning Python, but you don't have to have letters there. You can have numbers inside the quotes too. The floating point number, pi, 3.1415, it's any number where the precision extends to the tenths, hundredths, any decimal spot. But what is a variable? A variable is a name we use to refer to the value in our code. It lets us do the same thing to potentially different values, change the value, and lead to different results. So you might remember concept of variable from algebra, say, something like 5 minus x equals 3, solve for x. It can function the same way in a program in terms of being in part of a mathematical operation. But when we assign values to variables, we're starting at the point of assignment. We're not solving for what the value truly is. We're telling the program what value to assign. So here we have variable 1 equals quote 1, variable 2, hello class, happy to meet you. Just an example of how we can have numbers within a letter string. And variable 3, 54724. So here, the way to read these lines of code is to actually start on the right. See the value that's there. The single equal sign doesn't ask or imply any kind of equivalence. It's not a condition. It's either true or false. In Python, for that, you use 2 equal signs together. A single equal sign is an assignment statement, saying that the value to the right of that equal sign should be assigned to the variable name on the left. So what types are the values stored by each variable? Variable 3 is a number with a decimal point. We call that a floating point number. Variable 2, hello class, happy, hello class. We'll just make it shorter, it makes sense. Hello class, enclosed in quotes, so it's a string. Variable 1 is the number 1, but it's also enclosed in quotes, and so it's also a string. If we were to delete the quotes there, that line, that assignment statement is still valid right here. And the data type for variable 1 would now be integer. So the variable is a name that refers to a value. You might think of it as a box storing a value. You can set up, or you could write a set of instructions what somebody would do to a box, carry it, put it on top of your head, raise it, lower it, turn it around. And all of those motions would act on whatever's inside the box too. In computer programming, we often want to do the same thing to a set of different inputs. And what we can do in our code is write the instructions to act on a variable, and through the execution, change the specific value that is assigned to that variable. With variables, we can assign values to them, we can check the values, and check the data types of values. In Python, in contrast to some other programming languages, a variable does not need to be declared before being used. Simply assigning a value to it renders it as a variable being used in the session. Here are some examples of the different functions, the different things we can do to variables. We can assign them values, check the values, and check the data types. So assignments here make use of the single equal sign. We're saying for our variable called message, we're going to assign a string, the string Python version 3.4. To our variable n, we're going to assign an integer number, 17. To our variable pi, a number 3.14159. We can check the values stored in the variables by printing that variable. What would show up in the shell is the value associated with it. Finally, we use the built-in type function. We can see the data type of the variable. So I will go into idle. As soon as I'm logged back in, I'll go into idle. There we go. And just test out one example of this. And I urge you to do so yourself, whether it's on the virtual desktop or any computer. So I'll work with the integer. N equals 14. Print n. So I assigned a value of 14 to a variable called n and check the value of it, print n. I can look at type of n, class int for integer. Now we can change the value assigned to n. Here I put the numbers 1 and 4 in quotes. Print n. What's it gonna be? It's actually gonna look the same. But when I call the type function for n, we get a different result. Class str for string, because it's enclosed in quotes. N equals 14.0, print n 14.0, so we get a slightly different thing printed. And when we call the built-in type function, and within the parentheses after that function, write the variable n, we get class floating point. So variable names, how should we pick the names for our variables? I mean, n, that kind of makes sense as a number. You have a lot of free reign to pick the names you want. Now there's some reserved words in Python that refer to kind of built-in functions that you cannot use. Beyond those relatively few reserved words, it's a good habit to pick variable names that are meaningful in the context of the program, or at least simple enough so that you can recognize difference. And that might include something like an N, the letter N. So when you pick a variable name, it must start with a letter or underscore. So don't begin your variable names with numbers, but they might include numbers later on. case sensitive. In Python, really in any programming, lowercase letters are totally different from uppercase letters. If you want to kind of compound multiple words in your variable, you can't have a space between them, but you can use something called camel case, where you put a first word, camel, with a second word, case, could be any two words, but you capitalize the first letter of the second word, or the third if you have more, just to denote that they're different words. You can also use underscores within your variable names. So going back this, if I do print n, I will get a result. If I do print capital N, I don't. Capital N is totally different from lowercase, and it's not recognized as a variable that's used. If I want to create a new variable, call it M, I can call it M1, assign it a value of 2, and that prints out. I can't call it 1M, invalid syntax. My variable cannot begin with a number. And when I talk about camel case, let's see. One example might be number of students in the class. Number of students equals 5. So that's what I mean. If you capitalize S, the first letter of the second word, just a little bit easier to read. Oh, freezing up on me. If you keep that S lowercase, it's totally valid, just perhaps a little harder to read. Here in the slides are just some of those keywords, things like false, for, if, that you should avoid, you must avoid for your variable names. Data, float, numeric. And then there are some words that are not reserved in the initial version of Python that'll load when you start a new session, but they are reserved in certain libraries that you may want to access the code for. So if you import the library, you also cannot access these for your variable names. So for the library of math, which has some trigonometric functions, you can't call your variables cos for cosine or log for logarithm. Just be aware. I'll end the first part here. Start up with the second part of this video in a separate file.